Hi, everyone. My name is Theo. I'm a research product manager at Anthropic. I work on our long horizon capabilities, such as long context and memory capabilities in our models. I joined about 2 years ago, right when Sonnet 3.5 had recently launched. At the time, agents were barely a word that people were using. There were just signs of life that the models could even do coding at all. People were still focused on chat completions. Autonomy and agent autonomy was something that was still kind of a new concept. Around this time last year, when I go back to Code with Claude last year, Opus 4 had just launched. Claude Code was not even GA. It was still a pretty nascent thing. We didn't know if it would quite take off. It was still pretty new that models could be used for autonomous coding. And of course, now we have Fable, we have Mythos, and recently had also launched Opus 4.8. So before I go into the talk about the capability curve and how models have improved over time, I want to ask you all to raise your hand if you've heard of Claude. Okay. Now raise your hand again if you've used Claude. And keep that hand raised if you think Claude makes you twice as efficient. Okay? Keep that hand raised one more time if you think Claude makes you 10x as efficient. Okay, pretty good. This time last year, lots of people did not even know what Claude was. When I was at Code with Claude last year, people were still asking me, tell me a little bit more about large language models. What do they do? How can I best make use of them? And so it's really insane to walk around this conference and see how much more awareness there is around AI, how many more people are using it in their day-to-day life, and how many more people are not just using it in their day-to-day life, but seeing the gains in their own productivity and efficiency. More code is written by Claude every year. We recently released a blog post about recursive self-improvement. Over 80% of code internally at Anthropic is merged by Claude. And so, as you can see, as models improve over time, we very much expect that capabilities and the ceiling of those capabilities are only going to get better from here. And so this talk is about how you adapt to this new world and how you as developers can actually think about building for the future instead of just building for the past. So you can see on this slide that we have a series of models and how they've performed on SWE-bench verified. This is a trusted coding eval that we use internally to look at Claude's coding improvements. This eval is made up of a series of GitHub issues, and Claude needs to pass these issues and is then run on tests to see whether or not it has successfully passed that issue. And if you look all the way back to Sonnet 3.7, you can see that it scored just a little over 60%. With Opus 4.8, it is now scoring 88%. And with Mythos and Fable models, we have seen that this benchmark is actually saturated. This is a pretty insane improvement. I don't think the line fully captures how insane of an improvement this is. From 62% to 88% in just 12 months means that Sonnet 3.7 actually failed 3 times as often on these tasks. Just think about that for a second. And that is the rate at which models have improved just over the last year, and models are only improving faster and faster. And so what I'm about to show you is the same task done 12 months apart by 2 different models. So first we'll see Sonnet 4 performing on this task, and then we'll go and look at Opus 4.8 on the exact same task. The task that I'm about to show you is rebuilding Claude.ai, our Claude website, in one shot. And so Sonnet 4, as you can see, is writing quite a lot of lines of code. It's calling a lot of tools. It's jumping right into it. It's acting before it's planning. And when you actually go and run the UI, you can see here that it actually doesn't work. looks reasonable, but not completely functional. Now, the Wi-Fi might be down. I'll voice over what Opus 4.8 would have done on this instead. Opus 4.8 would have built the exact same UI, but it would have actually had the same colors that we would have had on the Claude.ai website. You would have seen the sidebar. You would have seen the chat interface. You could actually send messages, and they would actually respond correctly. And it would plan before acting. And not only would it plan before acting, but that planning before acting would ultimately lead to far fewer tool uses called, far fewer lines of code written. And so at the end of the day, what you're seeing is that Opus 4.8 not only does the task more successfully, but faster and cheaper. So before I get into the tactics of how you can actually build in this new world, I want to talk about where the intelligence gains are actually landing. So the first thing that we'll talk about, again, as I mentioned, is this idea of planning before acting. So old models would, be like me with IKEA furniture. They would jump right in, not look at the instruction manual, just kind of start building, and then kind of fail at doing the thing and realize that they had to go back and actually look at that instruction manual. So they would just kind of jump right in and act before they started planning. Now, models actually plan first, and what that means is that they're thinking through what the spec should be before they actually go and execute on it. And by doing so, as you saw, or would have seen if the Wi-Fi had worked, with Opus 4.8, is that the models are actually more efficient by pre-planning that spec. And as it's pre-planning that spec, it's then able to actually catch mistakes. So you might see things like the model saying words like actually or never mind. But by catching those mistakes, it can actually execute on the plan more efficiently the first time around. And so what this means for you is that you should allow the model to think first before actually doing the task. Build your products in a way where that thinking is allowed in the user experience, where you are actually giving the model higher effort and adaptive thinking so that it can then do that planning up front. The second area where we see a lot of intelligence gains is in error recovery and self-correction. What I mean by this is that old models used to do this thing called doom looping. Doom looping is the idea that the model would be given a task. It would go and do that task. It might fail on the task. You would tell it, hey, I think you should have done this other thing, or maybe something in the environment gave it feedback that it should have done this other thing. It would say, great, let me try it again. And as it tried again, it would just kind of keep running into the exact same solution that it had previously and would not change its approach. Now, models are able to actually look at that feedback and react to it. And they will actually try something different and try again. And oftentimes, this leads to a better outcome. And so what this means for you is that you should think about designing your environments in a way where you can actually give that feedback to the model so that it can actually then recover from any errors that it's hitting along the way. And this also means that instead of doom looping and just wasting tokens, models are actually able to perform the task with fewer tokens overall. And finally, models now are improving at running over longer and longer horizons. What this means is that models are actually able to sustain attention and hold coherence up to often 1 million tokens, sometimes even more. Old models would lose the thread partway through. They might forget the task. You might have heard people say that sometimes they see models, quote unquote, losing the plot. This is often what people say when a model kind of forgets the task along the way. Maybe it forgets the instructions along the way. And so it kind of starts going a little bit off what you expected it to go on. But now we're seeing that this has improved significantly more. And of course, there's still room to improve here as we get better at longer context lengths. But now you can actually allow the model to run up to a full 1 million tokens. And what that means for you is that you don't have to do as much context management. You don't need to chunk up the context window as much as you used to. Though, of course, if you do want to run for much longer than 1 million tokens, you may still need to do some of this. So I'd recommend, as you think about models going for longer and longer horizons, that you actually just dream more ambitiously and give it much longer tasks where you can hand it an entire code base and not just a single file. And what this means is that models now can plan a lot better. They run into fewer failures as a result, but when they do run into those failures, they're able to recover more quickly. And finally, they can just run for longer and longer horizons. And so all of this compounds into these agents that are able to run a lot more autonomously. And they can then do longer and longer tasks over time, and so they're able to then do more and more intelligent tasks over time. So what this might look like is something like the chart you see here, where agents first plan. After they plan, they then execute on that plan. You might give them some way to verify against that executed plan. So maybe, again, this is human feedback in a conversation, or this is some tool that the agent can call to verify their outputs. They then use that verification to then adjust the plan, and they kind of go back and loop on this again until finally they are happy with the final result. But don't just take this from me, take this from some of our users as well. Here we have a quote from Shopify, who has seen that Claude Opus 4.8 is noticeably better at error recovery, at planning before acting. Cursor has seen that tool calling and token efficiency in our models is much improved, and that Opus 4.8 is better than every other Opus model that they've tested. And similarly, Cognition has also seen that Opus 4.8 is much more autonomous, can run for much longer horizons, and similarly is also more token efficient. So again, as models get more and more intelligent, you can kind of just let them go for longer periods of time, and they're able to work on tasks more efficiently and effectively than they were previously. So this is the part where everyone's probably most interested in, which is tactically, how do you actually now build for this future? How do you build for the models that are getting better and better over time? This is not just about Opus 4.8 or Opus 4.7 or any of the models that we have today. This is really about helping you guys understand, as models improve, what should you be thinking about as a developer so that you can actually give your users those intelligence gains that we're seeing in the models. And the first thing, before we even get into the tactics, is a mindset shift. Be ambitious with what you try and what you allow Claude to handle. Don't keep testing the same tasks that you think Claude could have done 12 months ago. Start to think about tasks that Claude can't do today, and think about how you continue thinking about tasks that Claude can't do today, because as models improve, more and more of those tasks are going to be possible, and you want to be able to see as those tasks become possible. And the first way that you do this is by building evals. Refreshing your evals if you already have evals, but oftentimes this is the first step for people to even understand what is possible in models today. So if you don't have evals, the way to think about this is that they are unit tests for the AI era. Some of these can be regression test-based, where these are all tests that the models today can already do, and you're just looking to see whether or not your harness or future models are able to do the same things. But often, what you actually want to do is create evals that today's models do not saturate. And so what this means is looking not just at the current customer experience that you're providing to users, but the customer experience that you want to provide to your users over time, and the direction that you want to take your application. And building for those test cases and putting those test cases in your evals. This also means looking for failure modes that your users are reporting to you, adding those to your evals, and seeing if new models actually then solve those failure modes. Secondly, update your evals that might be saturated. So we sometimes hear from customers when we launch new models that they'll say something like, hey, on my eval, it only really improved by 1%. I don't think this model is that much better. And over time, as they start to play around with the model more and more, they realize, oh, actually, this model is significantly better on a couple of capabilities, or maybe this one axis that my eval just didn't test for at all. And so this is a testament that if you're seeing that your eval is not moving very much, you may want to look at whether or not the remaining problems that are not yet solved by models in that eval are actually fair and solvable. And if they're not, then your eval might be saturated. And if it's saturated, then it's time to update that eval and look for harder problems. And finally, once you do have that eval, the best thing that you can do is just benchmark it so that you understand how various models are performing on it, and as new models come out, to actually then look at how those new models are performing on it. Secondly, and I can't say this enough, shrink your scaffolding. Scaffolding is the prompts around the model, the tools that you might be using around the models, any code that you have. Sometimes people also call this the harness. But as you look at your harness and your scaffold, oftentimes people are adding new things to it over time because of various failure modes that maybe prior models ran into. And so an example here is that we, at one point, had a line in our Claude AI system prompt that specified a specific citation format that was now out of date and was not a citation format that we were using anymore. And our new models got significantly better at instruction following and started following that instruction in the system prompt that we had put in there a while ago. And so we thought that citations were broken in this new model until we looked at the system prompt and realized that actually the model had just gotten better at instruction following. And what we really needed to do was to just remove that line entirely from the system prompt. And this is an example where shrinking the scaffolding and just letting the model have a little bit more autonomy actually helps you to see what that model can do in practice. And so what you want to do is to write your prompts for intent and what you want the model to ultimately do, and not just to write those prompts around all of the past failures that you may have run into with prior models. And finally, you want to give the model room to work. So we talked a little bit about this when talking about giving the model room to think. You want to use adaptive thinking, which gives the model the ability to decide when it needs to think and how much it needs to think. And there's also an effort dial that you can use to actually dial up or down how hard the model works on problems. Secondly, you want to allow your agents to have more access to your environment, to take more actions, but do so in a controlled way. So as we talked about, models are becoming more and more autonomous. They're becoming more intelligent. But to actually take advantage of that, you need to give your model the actions and the capability to take those actions. And one way that we do this internally is that, as we talked about in a recent blog post, we launched auto mode in Claude Code, which is a classifier that tells Claude what actions are safe to take. Of course, you don't want to just allow your model to kind of run wild and maybe delete everything in its environment. And so you do want to be a little bit controlled with what it has access to. But doing it in this kind of classifier way allows us to kind of strike the right balance of how much control we want to take, but also how much control we want to give the model. And finally, you want to close the agent loop. And what I mean by this is that, as we talked about before, models are now very good at error recovery, but it needs to know when it has made an error. And so the way that you tell the model whether or not it's made an error is by giving it a way to verify its outputs. So for example, maybe if you're building an application building agent, you might want to give it a computer use tool. And with that computer use tool, it can then QA the front end, it can click around, it can see if it actually works. And that way, it can then get that feedback from its environment to understand if it should then go and update the code. So with that, thank you so much for listening to my talk on the capability curve. Hopefully, you have learned how to think about models improving over time and how you can build for that future. Arigatou gozaimasu.